Right. Thank you for giving me the opportunity to present one of the upcoming fields into the industrial realm. That is the organic fertilizers. So I would start here by stressing on what the soil condition that is right now is typically in India. So in 70s when we had green revolution, we had nice and abundant organic carbon in the soil. The soil texture, the soil chemical properties, biological properties, was everything was in pretty much in place. Our challenge was to improve the food productivity. Since we did not have better yielding seeds, also, symbiotically, we did not have proportionate fertilizers and pesticides. So the challenge was daunting, and it was a very tedious task. So I really I congratulate the the agricultural scientists that time that had come that had got this green revolution in place. But having said that, what also happened was that we there was a skewed relationship between input and output. Soil from being a heterogeneous system where the soil was revered as not just a output medium or a source of production, but much larger than that. It was revered as a part of who we were. So essentially, that link got broken. People started using soil for just for production purpose, and start taking it like that. So we started using. Having said that, we started using synthetic fertilizers in an imbalanced way. So initially, we were focused on nitrogenous heavy and phosphatic heavy fertilizers. So the main two important nutrients that came to be were nitrogen and phosphorus. So excess use of nitrogen and phosphorus led to increase in production for a while. But after that, we saw that the plateau had more or less reached. So what happened then? The important thing that happened in the last decade specifically, that Indian soil had seen a significant decrease in the properties. The carbon content, the carbon and organic matter that were present in the soil came down from 3.5 to different soils to zero point 0.3, 0.25, and even less in some places. So would you believe that we have seen a tenfold decrease in the most essential nutrient that we require? So, and not just that, the second big problem that came into front was the imbalanced use of fertilizers. Like I'm saying that we use mostly nitrogenous and phosphatic fertilizers. The other secondary elements and micronutrients, and very importantly, potash, which was abundant earlier, was reduced in a much lower level. So therefore, we saw that a plateau had reached for production, and for we saw simultaneously increase in pest incidence, increase in water usage, increase in factors of production, and therefore making it more strenuous on the farmer. The dwindling yield accompanied by a higher cost of production, more instances of crop failure, biotic abiotic stress, maybe it could be climate or pest incidents. So overall, the scenario is looking quite grim. So so that is the backdrop of where we stand right now. Now, now having said that, there is also a silver lining here, that being that India has not really worked on organic fertilizers. We have worked on biological fertilizers like different nitrogen fixation bacteria, phosphatic, potassic, trichoderma, pseudomonas. We have worked on microbes for sure, and there are some good companies that have worked on microbes. But what has happened is that we have skipped the single most important link in the chain. That is the carbon and nutrient availability in the soil. And that can only be achieved if we use organic fertilizers. So traditionally, India was using organic fertilizers, but the the kind of use that we were doing was pretty preliminary, or so to say, in most cases redundant, because we are only using cow manure now. But there was a need to upgrade that. So there has been some good instances, and we at Terra Agrobiotech, we can proudly say that we have worked on not just one, but we have worked on almost all essential 16 nutrients, and that too in complete organic way. So just I'll just share you the the important thing that we are mentioning here. So we have created a product range. It's called Carbon Series products, where like I was saying that we are tackling the issues of increased soil carbon and bioavailability of fertilizers, tackling providing better output to the farmer in terms of quality and quantity. So all that we are doing through our fertilizers that have nutrients, that have the biocontrol agents or biofertilizers and carbon in them. So generation fertilizer that is carbon plus nutrient plus fungi. Mechanism how they actually work.
Sir, your
So
voice is
now is
breaking, sir.
particularly today. Is it fine now?
Now it is fine. Now it is fine. Go on, sir.
Yeah. So today, so coming back to today's topic, uh, uh, about a particular fertilizer that is of the question today. That is called PROM, phosphate rich organic manure, and we are also working on phosphatic fertilizer. So the product we have named our PROM is Terra. Now, PROM, how does it differentiate from DAP? So if you can see this slide, you
Yes,
can
sir.
see that synthetic
Sir, your
fertilizer
voice
and
is
even
breaking. Hello. Sir, your voice is not clear.
is it fine? There is
Hello.
an internet
Sir,
issue,
you are able to
but
hear me?
hello,
Hey, can you just check
hello.
your network connection, sir? Your
Yes,
voice
I
is.
can hear you. I can hear you. Just give me a second again.
Yes, sir. Yes.
I'll just check. Is it better now?
Yes, sir. Now better. You go on, sir. I will alert you when it is not. Okay.
Yeah. Okay. So, right now we are talking about the mechanism and the mechanism for uptake. So now this slide basically talks about how synthetic fertilizers like DAP, urea, MOP, and other like zinc sulfate and other work. So essentially, when you use a synthetic fertilizer and when it is applied in the soil and it is watered, the fertilizer gets converted into water soluble form, number one. That is through application of water. Now for the water soluble fertilizer to further be used by the plant, it has to be converted into ionic form. So like for DAP granules are first applied. When we water them, P2O5 is released. Now P2O5 is further converted into ionic form. And how does that happen? Ionic form conversion basically happens in the soil through the complex mechanism of microbe interaction. So when P2O5 is broken into orthophosphatic form, that is the form in which the nutrient gets absorbed by the plant. So now the after getting converted into orthophosphatic form, the nutrient will be supplied through the roots. But the thing here is that the soil should have important components like biological, symbiotic biological association, which means it should have a lot of symbiotic bacteria which will break down the phosphorus into orthophosphatic form. In this case, it is called PSB, phosphate solubilizing bacteria. So it solubilizes and converts the nutrient into soluble form. So for the microbes to function, the soil needs to have good amount of carbon in them. For the microbes to stabilize and function, also the soil texture needs to be have the right balance. It should not be, let's say, aggregates, or it should not be into lumps, or it should not be sandy. So the soil has to have right kind of structural balance. So only then the microbes get active and it is absorbed by the plant. But what has happened is, because of the low carbon content and because of the poor condition of the soil, the pH has gotten high, the EC has gotten high, and mostly the soil is the carbon is low, and therefore the soil becomes not viable for the bacteria to propagate, and hence making the soil dead. So that is the biggest challenge. And we've seen that because of that, there is a lot of damage happening to the soil health, to the plant health, and to human health, right? So we are fixating the soil, we are making it so hard. So the worst thing that DAP does, or any synthetic phosphorus fertilizer does, is that it fixates in the soil. And when fixation happens, the soil becomes harder and harder. One of the big reasons why there is use of tractors with higher horsepower is that they need to plow deeper, they need to plow harder. For that, we are seeing an increase performance factors of in terms of HP. So that is because of phosphorus, and primarily that is because of synthetic phosphorus in from DAP, MAP, or whatever, because that gets stuck in the soil and it is further killing the life in the soil. So what do we do? So for that, I will come to improving organic matter, improving carbon content, improving the associated microbes, and making nutrient available in bioavailable form. So like DAP, in this slide, as you've seen, it is only and only 20% available to the plant. If it has a 46% P2O5, out of that, only 20% gets absorbed, which is around 9%. Right? So that is one challenge. So what have we done for it? We worked on complete solution, not products. We strive to get best combination, not isolated variants. Products are designed for optimizing soil health and mostly for soil application. First of its kind, carbon-based products with relevant biological strain along with nutrient. So this is the range that we are working on, whether it could be primary, secondary, and micronutrient. In primary, we are working on nitrogen, phosphorus, potassium, secondary, calcium, magnesium, sulfur, then all of the micronutrients and the auxiliary elements like carbon, hydrogen, oxygen. Like we all know how important is carbon, because carbon has become so important not just in terms of carbon sequestration and improving climate condition, reducing temperature, but also for soil life. Uh, so uh, so we can use now coming to PROM specifically. Now, this is one of the products that we have, phosphatic fertilizer. The product category is PROM. The product's name is Terra. Uh, like I mentioned about primary background of phosphorus, why it's important, like for plant growth, for root development specifically, and specifically for, initiation. Uh, it is used primarily in the earlier stages. uh, Now, products overview. Terraphos, we the product that we are creating has a phosphorus which is around 10.5%. There is calcium in it, there is carbon in it, there is PSB in it. All that is present. Now, the USP of the product is that it has a very high biological availability. Unlike DAP only has 20%. It has almost a near 100%, at least more than 80%. Why? Because it is the product is created by making the phosphorus bioavailable through a process called co-composting, where the rock phosphate is unlocked. The phosphorus from rock phosphate is unlocked through bacterial degradation of rock phosphate and enzymatic reaction, but done in a natural way by a process called co-composting. When you compost rock phosphate, minerals, and other important parameters with organic matter, providing them symbiotic bacteria, natural enzymes, and so on and so forth. So therefore, the product becomes absolutely synergistic with the soil. It's like creating a soil beforehand and then making it a part of the soil when you apply. So there is pretty much no time lag. It is not like you put the product and it will come work later. Unlike the misconception that organic fertilizers work slow and late, Terraforce works pretty fast. I mean, and is highly available. Uh, it is a good source of also good source of calcium, some sulfur, and some nitrogen. Then I have talked about this. These are some trials that there are that we have conducted. The product specification as per FCO. FCO is Fertilizer Control Order, which defines the product composition and characteristic. According to FCO, these are the characteristics that should be there in PROM. Let's say moisture maximum by weight should be 15 to 25%. Why this is important? Because PROM has PSB in it, and for PSB to function, there has to be moisture in them, right? So that is one. The particle size should uh, be less than 4 mm in size. So even if you are granulating, so we are making PROM granules. Why granules? Because it is compatible with modern agriculture. It can be used with the seed drill at the time of sowing, and unlike the other PROM that is in powder form, which is application is slightly tricky because it has to be, you know, it has to be broadcasted, and broadcasting is typically a process that is very tough to get accuracy for. So we have gotten granules that can be used. So the granule size is 4 mm, should be 90%. Bulk density should be 1.64. What is bulk density? Bulk density is the kind of weight that is there in the particular volume, weight by volume, basically. So what is the weight by volume? 1.64. It should not be more than 1.64 because PROM has a lot of minerals in them. Bulk density is more than 1. It is so less than 1.64. Nitrogen has to be 0.42. Phosphorus has to be 10.42. The potash is not a mandate. CN ratio should be 18.7 is to 1. Should be less than that. pH should be 6.72. Conductivity should not be more than 8.27, and heavy metal should be under this range. So that these are the specifications for PROM. PROM per se has really worked. It is really working out, and it is coming as a substitute for DAP, and it is even better than SSP. SSP being single superphosphate, which has 16% P2O5. and DAP has 46% P2O5. So on those both regards, prom is a better and a more viable form, because it provides other nutrients as well, and it also replenishes the soil. So prom, if made in a correct way, if fortified with important nutrients and enzymes and microbes and other things, can be a really powerful product. So now also, adding to what I'm saying, I'll just show you the kind of, price variability that we have seen when it comes to prom versus uh, other products. So I'm just taking you to us its presentation now. Just a second. Yeah. So, you can see from the slide, India's right. So for this slide, I'll be focusing on the economic and the financial implication of various fertilizers, and specifically phosphatic fertilizers, and why it becomes necessary, even more necessary, uh, to replace all these with indigenous made, uh, less cost intensive products like prom. So India's DAP imports uh, have been declining from 5.6 million tons a year to 4.7 million tons this year. So there has been more than a 20% decline, and the domestic production of DAP has also declined from 4.2 million tons to 3.7 million tons. Uh, so that is one thing that we are seeing significantly, that the production, the government is also focusing less and less for DAP production and importing lesser. The other thing that is of relevance here is that globally, DAP prices have shot up from $552 per ton last year to $699 per ton. That is FOB Gulf. So that's freight on board, basically FOB. That is the price on landing basis. That is there. So we've seen that the prices have gone up. Uh, so that is there, and we've also seen the if you talk about the price volatility, DAP was 19,900 rupees ton uh, in 2020, and which surged to 50,000 rupees ton in early 2030 and 24. Which is a significant, very highly volatile product. So you can see that it has become almost 2.5 times in a matter of 2 years, and which is really risky for Indian scenario, because farmers highly depend on DAP and urea for their production. So that is another big problem with synthetic fertilizers like DAP. If you look at cost comparison per ton basis, DAP, which has a 46% nutrient, PROM has 10%. Cost of DAP is 47 to 57,000 rupees per ton. Cost for PROM is high on it. It is on the higher estimate. The highest price for PROM would be 20 to 25,000 rupees ton maximum for the farmer. So that is there, and also then the government has to give a lot of subsidy. So therefore, you can see that there is so much of uh, you know uh, cost differentiation. So the other thing that I would want to show you is that per ton phosphatic cost, if it's not mentioned, per ton phosphatic cost comes down to approximately it is 3 times the cost of phosphorus from prom. So all I'm saying is that the benefits of prom outweigh the benefits of DAP in terms of soil health improvement, in terms of production improvement, in terms of price improvement for the farmer. That per ton of phosphorus, derived from is much cheaper than per ton of phosphorus derived from DAP. So therefore, per ton basis, cost basis, it is also better. So so that is some important considerations to note here. So in all, I would want to sum up by saying that PROM outweigh DAP and synthetic fertilizer on a lot of counts. Just that PROM has to be made and enriched to a level which not only provides carbon, phosphorus, and but also provides other important things which help the plant to grow and survive. So on that note, I would want to end here, and I would want to wish everyone watching this webinar, all the industrial partners, all academia people, all maybe even students, and make a request to them that let us not rob our soil for its life. We have to make the soil alive again. We have to make it nourished for us, for our future generations. And if we keep on exploiting soil like this by pumping more and more chemical fertilizers like this blindly, we will definitely ruin ourselves. So we have come a long way. We have created a kitty and working on organic fertilizers. Just that we need to be more involved in it. So on that note, I wish everyone watching this webinar, lot of blessings from the soil side, that let us do something for the soil and make it happen. Thank you.
Thank you very much, sir, for your presentation. I'll take up the questions now. In the meantime, can you please stop sharing the screen, sir, so that we can see your video? Yeah, I'll move on to the questions, sir. The first question is, which crops respond best to PROM application and why?
So all the crops that require phosphorus in them. So, the crops have a different nutrient uptake. Some crops would require more of nitrogen, potash, some would require more of phosphorus. Any crop that requires phosphorus, PROM can be applied. Just that we have to see the soil type. Let's say if your PROM has a pH of, let's say, 7%, if you're not decomposing it, or if there are not enough organic acids to it to reduce the pH in it, the pH could be higher, and therefore for soils which have higher pH, there could be some challenges. So I would recommend to also study your soil and see how we can improve the organic content in it, and thereby and also improve and reduce the pH. But otherwise, PROM is pretty much used everywhere wherever phosphorus is required.
Okay. How does the phosphorus availability in PROM compared with that of rock phosphate or chemical fertilizers?
So, like I said, there are many universities that have done the trial for phosphorus uptake and nutrient availability when we are using different form of phosphatic fertilizers. So they have compared rock phosphate, they have compared PROM, and they have compared DAP. So they have seen that the availability is highest for PROM, then for DAP, then for rock phosphate. Why lowest for rock phosphate is because rock phosphate is a mineral, and it will require a lot of breaking down from the soil's microbes and release of organic acids, which is hardly now present in the soil. I mean, it is at the lower spectrum. Then comes DAP. DAP has water soluble phosphorus in it in terms of P2O5, but the issue is that it will be converted into soluble form, but it will not be converted into ionic form because of lack of microbes, which result from lack of soil organic carbon. Therefore, even the 46% in rock phosphate is available only at a level of 20% or 15%. It is not, and it is now validated by different universities. Maharana Pratap University in Udaipur, Maharana Pratap Agriculture University in Udaipur have done elaborate trial on PROM because rock phosphate comes from Udaipur. Most of the mines are in Udaipur, and they have seen that how usage of DAP is becoming redundant.
Okay. How does PROM affect soil health, microbial activity, and overall fertility in the long term?
So when we talk about overall fertility, like I mentioned in my presentation, most important thing that is lacking in the soil is organic matter and organic carbon. That is number one. And also the other thing, very important thing is that all the nutrients are hard to get recycled. So when we are using nutrients now as compared to when we use nutrients some 40 years, 50 years back, the nutrient recycling and availability to the plants have reduced significantly. So PROM gives a promising solution because it recycles the nutrient freehand, and when you apply it in the soil, it is readily available to the plant because PROM itself is a part of the soil outside the soil. And when you put it in the soil, it becomes easily integrated in the soil, and therefore the availability of nutrient is of the higher grade. Yeah. Am I audible?
Yes, sir. I'll move on to the next question. What are the major challenges faced in promoting PROM among farmers?
The major challenges that are faced, promoting PROM are manifolds. Firstly is quality and consistency. Since PROM production is not cost heavy, so there are no barriers to entry. Unlike DAP and urea, PROM production can be started at a you know, much reduced financial investment, therefore making it easy for a lot of scrupulous and fly-by-night operators which are not making consistent quality. So therefore, one issue is that the PROM manufacturer themselves are, the liability issue has to be stringent, which I'm sure the government is making. Since it has gotten it into FCO, they are doing more and more samples and they're working on it. So that is one part, is quality production of PROM. Second part being that also, since DAP is highly subsidized, there is around 20 to 25,000 rupees ton of DAP subsidy, NBS, nutrient based subsidy, that is available on for fertilizers, which makes PROM manufacturers even even more varied, because they have to compete with the subsidy and they are not getting any subsidy. So the government support is also lacking when it comes to PROM. They have started with MDA, market development assistance, but I'm sure it's some time for it to happen. So that is second. Third is the farmer's acceptability also. So the farmer have historically been, I would say, I would not say brainwashed, but they have only been given this option. And because of excessive use of DAP, the farmer is fixated, on usage of DAP. His mind is fixated that he needs to use DAP no matter what. So that is another challenge. And the last challenge being that uh, availability of PROM is also a challenge. So, a lot of places PROM is not really available. It is available in maybe in Rajasthan and a few other states where there is rock phosphate, but in other states people are still, very. It is nascent only, new only. So that is another challenge. Yes.
Okay. What government policies or subsidy schemes are available to encourage PROM usage among farmers?
So there are for different, government subsidy. One is, if they are using, there are subsidies on organic farming. There is a scheme called Paramparik Krishi, uh, PKMY. Uh, so it talks about the Paramparik Kheti. So there is subsidy available in that as well, and various others. So the best thing for the farmers would be to get in touch with their AAEOs, extension officers. They can tell more about the schemes, local schemes available. For in Rajasthan, we have a few, like Paramparik Krishi is one, and organic farming clusters is another. So these are the two things where government is trying to promote organic farming and making It incentivized if farmers, form clusters and do it.
Thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we like to thank Mr. Abhishek Singh for the talk and for answering the question. This meeting will now be closed.
Thank you. Thank you.
You're most welcome, sir.